Anikate Koul, and today we'll be discussing the fifth problem on the CP-31 sheet by TLE Eliminators under the 1200 problem. So I'll be moving to the CP-31 sheet, and we can see that the 1200 parameter has been checked. So I'll be moving down to find my fifth problem, Vika and the bridge. Let's begin. Now the problem statement is as follows. In this summer, Vika likes to visit her country house. There is everything for relaxation, comfortable swings, bicycles in a river. There is a wooden bridge over the river consisting of N planks. It is quite old and unattractive. So Vika decided to paint it. And in the shed, they just found cans of paint of K colors. After painting each plank in one of K colors, Vika was about to go swinging to take a break from work. However, she realized that the house was on the other side of the river and the paint had not yet completely dried. So she could not walk on the bridge yet. In order to not spoil the appearance of the bridge, Vika decided that she would still walk on it, but only stepping on planks of the same color. Otherwise, a small layer of paint on her sole would spoil the plank of another color. Vika also has a little paint left, but it will only be enough to repaint one plank of bridge. Now Vika is standing on the ground in front of the first plank. To walk across the bridge, she will choose some planks of the same color after repainting, which will have numbers 1 and then less than equal to I1, less than I2, so on, less than IM, and then less than equal to N. Now, Vika will have to cross I1 minus 1, I2 minus I1 minus 1, I3 minus I2 minus 1, and so on till IM minus IM minus 1 minus 1, and then N minus IM planks as a result of each of the M plus 1 steps. Since Vika is afraid of failing, she does not want to take falling. She does not want to take too long steps. Help her and tell her the minimum possible maximum number of planks she will have to cross in one step. If she can repaint 1 or 0 plank a different color while crossing the bridge. Now coming to the input format and the constraints, the first line of each test case or test file would contain a single digit t denoting the number of test cases. And then for each test case, the first line would contain two integers n and k denoting the size of our array, that is the number of planks in the bridge, and k which denotes the number of different paints that Vika has. Now the second line of each test case would contain n integers c1 till cn, where each ci lies between 1 and k, denoting the color in which Vika painted the planks of the bridge. Now it is also guaranteed that the sum of n overall test cases does not exceed 2 into 10 power 5. Now for every test case, we have to output a single integer denoting the minimum possible maximum number of planks that Vika will have to step over in one step. So now as we have read the problem statement, let's try to understand it in a better way. Now we know that for every test case, we have been given three things: n, k, and let's say c. So n and k are integers and c is an array. Another important thing to note that n denotes the size of our array C or the number of planks. K denotes the number of colors that Vika possesses. So each plank would be colored in one of these K colors. Then C describes the coloring, right? So C of I tells me in which color ith plank is painted. So let's say if C of I is 3, that means the ith plank is painted in the third color, right? Now it is important to understand that K lies between 1 and N, right? So you can have at max as many colors as you have planks. Now let's understand what the question is asking. It is saying that let's say you have different planks. So for our case, let me denote them by three different colors. So let's say we have some green planks. This is a green plank. This is a green plank, and then you have a few red planks. Right. And you might also have a few. Oh, this is a different color. Let me choose a solid color instead of a gradient. So let's choose, I have green, so let's choose blue. We have a few blue planks as well. Right. So how many planks do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 planks. Now what Vika decides to do is that only the planks that have the same color would be traveled. Right. So let's say Vika chooses the color green. Right. So what would happen is, firstly we would step onto the color green. Right. Now I cannot move to this plank or this plank, right? Without repainting it. We'll discuss what repainting means. But as it is, I can't move from the green plank to a red or a blue plank, right? I have to go from a green plank to a green plank, and so on like this, and then like this. This is how I or Vika would travel if uh, it was decided that only the green planks would be traveled. Now let's see what would happen if it was decided that only the red planks would be traveled. So something like this, like this, and like this. And so if only the red planks would be traveled, these would be the jumps that would be taken into consideration. Now also let's see the size of these jumps. Like a size of a jump is the number of planks that you jump over, right? So the size of this jump is 1 because you jump over one plank. Here you jump over no planks because you just move to the adjacent plank. So this is 0. This is 2. This is 3, and this is 1. So let's say it was decided that I move only over the red planks, then I have to tell the maximum jump, right, that I take. So this is the maximum jump that I take, so it is 3. If I take only red planks into consideration and I jump over only the red planks, then the maximum jump that I would have would be of size 3. But here comes the interesting part. Now Vika has also the option to color at most one plank into some other color, right? So let's just take red into consideration, right? So Vika has the option to color at max one plank to red, right? So let's say Vika chooses the eighth plank for that matter, right? Let's say Vika makes this eighth plank red. So let's see what happens now. What happens now is that you would jump in this manner, right? So instead of this 3, I'll erase this 3. You would have jumps of 1 and 1, right? So now your maximum jump becomes 2, right? So what you can do is minimize your maximum jump by coloring at max one plank to any color that you wish, right? And now you have to tell what is this minimum possible maximum jump, right? Over all the possible combinations that Vika can consider. This is the question. Now, in order to understand it uh, a bit better as well, let's look at some sample cases, right? So let us move back to the question and let's see this case, right? So let's move back and paste this case here. Also, I'll remove any extra thing, and let's also increase the font size so that it is visible, right? So now this 5 is our n, or the number of planks, 2 is k, or the number of colors, and this array is the array C, denoting the coloring, right? So what it says is, let's say if 1 was red and 2 was green. So the planks would look something like this. So I would have a red plank here, a red plank here, something like this, and in between I would have a green plank. So now what Vika can do is take this red plank and make it red. Oh, sorry, take this green plank and make it red, right? Because Vika can choose at max one plank to repaint, right? Now let's see the jumps. If now Vika chooses only the red planks to be traveled upon, you can see that all the jumps are of size 0, right? So the maximum jump size is also 0. So the answer would be 0 in this case, and we can verify that from the sample cases that yes, indeed our answer is 0. So this is how Vika can operate. Now let's move on to discuss the exploit time complexity. Now looking back at our constraints, we can see that n and k can lie up to 200 n power 5, and it is also given that there is a bound over sum of n overall test cases. So that means sum of n overall test cases is less than equal to 2 into 10 power 5. That also means that instead of writing my time complexity as O of t into some function of n, I can simply write it as O of some function of n, because n has a bound over all test cases. Now, another thing that needs to be kept in mind is on Codeforces, we can run approximately 10 power 8 elementary operations in 1 second. So that means our time complexity, if it is equal to O of n, then it would take approximately 200 n power 5 operations, and this would fit within the 10 power 8 bound. Even O of n log n, where it is base 2, we can say it would be around 200 n power 5 into, let's say, 20, approximately 20. And this would come out to be 4 into 10 power 6, which is again well inside our bound of 10 power 8. But if we move into the O of n square territory, then it would be around 4 into 10 power 10, which is much larger than a 10 power 8 constraint. So what we actually want is an algorithm which runs in the approximate time complexity of O of n or O of n log n. Now, keeping this in mind, I think we can move on to discuss the solution. Now, an interesting thing about the problem is that we can kind of brute force overall possible options. What I mean by that is, if you look carefully, sum of n oral test cases is less than equal to 2 into 10 power 5. That also means that any test case, a single test case, can have an n as large as 2 into 10 power 5. Right. But it is also known that k lies between 1 and n. So even k has to be less than 2 into 10 power 5. That means we can have at max 2 into 10 power 5 colors. Now, if for every color from 1 to k, if for every color I am able to determine what is the minimum jump that I can take if I only travel that color. So let's say I choose the color I, and now I consider the maximum jump that I took while traveling only the uh, plates or planks of color I, and then I compute that for all colors from 1 to k and take the minimum of them, then that should give me the answer, right? So I can have at max n, right? N colors. So let's take the worst case. I can have n colors, right? So what I want to do is to pre-compute or actually calculate this value, that the maximum step that I had to take for that color I. For every color, I need to calculate that in O of 1 or O of log n, right? Because if I do it in O of 1, my total time complexity would be O of n, and here it would be O of n log n, because I have to do it for all the planks. It would be actually O of k and k log n, but to simplify our approach, we can say that k can be at max n, and then I can use n instead of using k, right? So let's see how it is actually possible, right? And keep in mind, we have to take into consideration the repainting thing as well, right? We can't forget it. So what I'll do is that for every color I, right, for every color I between 1 and k, what I'll do is I will store a corresponding vector which will tell me all the indices at which that colored plank existed. So let's take an example where I have the planks of color 1, 2, 3, 1, 1, 2, 3, 1. Right. This is my coloring. Right. So if I check for the color 1, I can say that the color 1 exists on the plank numbers 1, 4, 5. This is 1, 2, 3, 4, 5, 6, 7, 8. So 1, 4, 5, 8. Right. And the color 2 exists on the numbers 2, and then this is 1, 2, 3, 4, 5, 6. 2 and 6. Right. And the color 3 exists on 3 and 7. Right. Let us store this. Now, how much time does it take to store this data? O of n. Right. O of n time. Because I have to just iterate once throughout the array. And what is the space complexity of this structured data? It is also O of n, because every index will occur in only one of the colors, right? There cannot be any repetition. Again, it is O of n only. Now, how does this method of storing information help us? Let's see. Now, also keep into consideration that I have to start before the first plank. So this is the first plank. I have to start before the first plank and end after the last plank, right? So what I'll do is for every vector, I will add 0 and n plus 1 at the beginning and the end, right? 0 and n plus 1. N plus 1 would be 9 here, so you can replace that 0 and n plus 1, right? Yeah, now you may ask, how does this help? Let's see the next step. How does this help? Now let's consider the vector only corresponding to the color 1. So I have 0, 1, and then I have 4, 5, 8, and n plus 1 is basically 9. Right. So now let's take and calculate the difference array, difference between the two consecutive indices. So this would be 1, this would be 3, and this would be 1, 3, and 1. But keep another thing into consideration. Let's see the problem statement again. It says that the distance is I2 minus I1 minus 1, right? Because if I am at the 0th plank and I have to move to the first plank, so I don't have to jump, right? I can just move, it's adjacent. So the jump would not be of size 1, it would be of size 0. So I have to subtract 1 from each value, right? Then it actually becomes 0, 2, 0, 2, and 0. But now what does this represent? Can you think? What does it represent? Yes, it represents the size of the jump that you have to make to move from one plank to the next one, right, of the same color. So if you want to jump from here to here, it will be of 0 size jump. This would be a 2 size jump. This would be a 0, a 2, and a 0. And that is represented by this array, right? So now if you just take the maximum of this array, it would give you the maximum jump that you have to make for that color. But we are missing one important thing, and that is to consider the fact that we can repaint at max one plank. Now, how do we take that into consideration? And that is very interesting. Let's see. Let's say I have a plank here of color red, and I have another plank here of color red, right? And I have, let's say, one, two, three, four, four planks in between, right? So I have to make a jump of size 4. Let's say I chose to color one of these 4 planks into red, right? So these are initially all not red, but I chose to color one of them to be red. So choosing which plank would be the most optimal? Try to think of it. The most optimal way to choose a plank for repainting would be to almost evenly divide. So almost evenly divide the gap between the planks. So let's say if I chose this plank to be recolored, then the new structure would look something like this. These two are red. I have three blocks in between, three planks in between, and this is again red, right? So the distance from 4 decreased to 3, right? The maximum distance. But let's say I did not do that. Instead, what I did was something like this. So initially these two were red, and I chose one that was almost in the middle. So now I have to make a jump of size 1 here and a jump of size 2 here. So the maximum value now from 4 it decreased to 2. So this is our main logic, that we try to choose almost the middle one so it evenly divides the gaps. And the other part is, for which gap do I choose this, right? And this is quite obvious, that for the maximum gap. So the maximum jump that I have to make, for that jump what I can do, I can choose the almost middle plank and make it the same color as the extremities, right? And it would almost divide our jump size by 2. So if I was making a jump of size 3 initially, if it was a size 3, now the jumps would be of size 1, right? And if it was 4 in the beginning, then the jumps would be of size 2 and 1, right? So that is how we do it. Now do this for every color, right? Do this for every color and then take the minimum over all the colors, and that will give you your answer. Now let's discuss the time complexity of this approach. We were expecting an n log n approach, right? Let's see, does this fit that criteria or not? So what we are doing initially in an O of n loop, we are trying to store all the indices for a given color for all colors, right? That is O of n. Then I am trying to find the difference array, that is again O of n. Difference array is this array that we just discussed. Now I'm trying to find the maximum value. So what I can do is basically put them in a priority queue or a multi-set. So inserting all these values would take O of n log n time, because there are n values, or n minus 1, but that is almost n. So n log n time to insert all these values, and then I can directly access the largest value in log n time, right? So now what I do, I access the largest element and then divide it by 2. So I divide the gap by 2 because I can repaint at max 1 color. So that is again an O of log n operation, right? So overall, what we do is the maximum complexity is O of n log n itself. So yes, it does satisfy the criteria. So this is how our solution would look like. And now let's discuss the implementation. So first we'll be taking input for the number of test cases. Then for each test case, I'll take input for n and k, right? Now we'll take an input of this vector v. Now this vector v, as given in the input, suggests that which color is the ith plank colored in, right? So the time complexity of this loop would be O of n, right? Because there are n planks to be taken input for. And then this is our array of vectors. So pay a note on the bracket. So this is an array of vectors, and the array is of size k plus 1. So this array of vectors will store in the following manner. So if I say colors of I is a vector which stores all the positions at which the ith color plank is occurring, right? So now, as I explained in during the explanation part, how does this work? First, what we'll do is we'll push back 0 for all the colors, right? Because we're currently standing at position 0. From position 0, we'll jump to some plank. Now I will push back into this colors array of vectors all the indices at which that particular plank is present. And now, as these indices are 1 based, so I will push I plus 1, right? So if I take a look here, this would be O of k, right? Just to maintain formal similarity, I'll use a capital K. This would be O of n, right? And again, because I have to completely jump over the bridge. So I'll have to reach the position n plus 1, right? So that's why I'll push back n plus 1 for every color, because I'll start from 0, then I will jump over the planks of that particular color and then finally reach n plus 1. That's why I do this. Again, this would be O of k, right? Now, what we do is we maintain an array of priority queues. Now, you may ask, what is the use of an array of priority queues? So, jumps of I. So, jumps, as I said, is an array of priority queue. So, every index of this array, like if I say jumps of I, will store a priority queue, and this priority queue will store all the sizes of the jumps that we have to make, right? So, as explained in the question, let's say I'm standing currently at 0, right? And let's say I'm jumping only over red planks. So I have a plank at 4, I have a plank at 9, a plank at 10, and the total size is 11, let's say. So I'll have to reach 12, right? So if there are 11 planks, I would have to reach 12 to jump over the bridge. So if these are the indices that are stored in my colors array of vectors, then the priority queue would store 4, because that is the difference, right? But if you pay a bit more attention, you may notice the following thing. So let me show it to you here. Let's say I'm standing at some index 0, right? So I'm standing currently here. Now there is plank number 1, plank number 2, plank number 3, and I'll have to reach at plank number 4. So if my jumps of I is storing a priority queue which tells me how many planks do I have to jump over, you might see if I'm standing at 0 and I have to reach 4, then I don't have to jump over 4 planks. I have to jump over only 3 planks, 1, 2, 3. So that's why I will write here 3. Similarly, I will write 4, because 9 minus 4 minus 1 is 4, and then 9 and 10 consecutive planks. So I don't have to jump over anything. So 0, and then I'll have to reach 12, so that is 1, right? So now these are the differences, and because by default in C++ a priority queue is a max heap, so we'll have all these values in descending order. So I'll have 4, 3, 1 and 0. This is how the values would be stored. So what I am doing inside this loop is just initializing my priority queue, as I just said. So now I go over all the indices of 1 to k on the colors of I array of vectors. And then for jumps of I tells me what are the sizes of the jumps that I have to make if I'm using the ith color, right? So I'm using the ith color. What are the indices that the ith color planks are present on? So that is given by colors of I comma j. So if I do colors of I j plus 1 minus colors of I j minus 1, that is nothing but what I did here. So this is colors of, let's say the red was the first color. So I can say that colors of 1 comma 0 is 0 and colors of 1 comma 1 is 4. So what I'll do is colors of 1 comma 1 4, that is 4, minus colors of 1 comma 0, that is 0, minus 1, that is 4 minus 0 minus 1, that is equals to 3. So that is exactly what I'm doing here. Now what happens here is, in the worst case, this can go up to O of n log n. And now you may ask, why is it so? Because in the worst case, it may happen that all the planks are of the same color, right? If all the planks are of the same color, that then colors of I will have a size of n, right? And in a priority queue, inserting any value takes log n time. So that's why total complexity would be O of n log n in the worst case. Got it? Now, what I do, because in the question it is given that I can change the color of at most one plank. So what is the most beneficial thing? As we discussed, it is the most beneficial to color a plank which comes in between the largest gap, right? So in this example, 4 is the largest gap. So if I color a plank to red, which is present in this gap of 4, then that would give me the biggest benefit. That's what I do. I take the largest value because it's, as I said, it's a max heap. So the largest value would be present first. I remove that value, and then this is the important part. So I check what is the parity of the maximum value. Let's say the maximum value is even. Let's say the maximum value was equal to 4, right? So it was 4. So that means I had 4 planks. One, 2, 3, 4. 4 planks, right? Now, in order to minimize the maximum gap here now, what is the best possible solution? As I said, to remove the middlemost, right? So I can remove this one, right? If I remove this one, now you may see that there is a gap of 2 and there is a gap of 1, right? So that's why I push back max val by 2 and max val by 2 minus 1. So for any even value, if I try to minimize the new gaps formed, I remove the middlemost value, and that gives me the original value by 2 and original value by 2 minus 1 gaps, right? So you can check it for 6 as well. So let's say if this was 6, now 3, 4, 5, 6. So what I can do is I can remove this plank because it's at almost in the middle. And now I have one gap of 3 and one gap of 2, which satisfies the condition again, because 6 by 2 is 3 and 6 by 2 minus 1 is 2, right? Otherwise, if the parity is, or you can say if the value is not even, if it's odd, then what happens? Let's take the example of 5. If I have 5, first thing that you can notice is that for even gaps, I will always have a middle element, right? For for even gaps, I had uh, two middle elements, but for odd gaps, I will have exactly one middle element. So this is the middle element, right? So I can remove this element, and then I have two equal gaps of 2 and 2 each. So that's why the gaps that are newly formed are max val by 2 each, and they'll be equal, right? And you don't need to worry because C++ division automatically truncates the values. So that's why pi by 2 is automatically truncated to 2. So you'll have two gaps of 2 each, right? And now what you need to do, you don't have to push the values again, or you can as well. So it is better that you push so that you don't have to check for a lot of conditions. Simply just push the values, right? After pushing the values, again, what was the clause? Minimize the maximum gap, right? So what you do, just take the maximum gap, which is again the topmost value in our priority queue, and then do this for all the colors, right? So if you can see, the outermost loop runs for all the colors, right? So if you run this for all the colors, you will have the minimum maximum possible gap, right? As the question says, and you just have to print it afterwards. And now you may ask, what is the overall time complexity, right, of this loop? Now some people might think that the inner loop runs n log n and the outer loop runs k, so it should be n into k log n. That is not correct. If you see that in the worst case where I said it goes n log n, I said that all the colors, all the planks are of the same color. And if that is the case, then this whole loop will run only once, right? Because you have to calculate the answer for only one color, right? So overall as well, what would happen is that your time complexity would go n log n plus k, somewhere around that, right? So it, you don't have to multiply both of these, because O of k and O of n log n cannot occur together, right? You can't have a condition where this inner loop runs n log n for all the k iterations, right? So if you consider the average case, it comes out like this, and that is also the worst possible case, because the worst possible case for a single iteration does not actually evaluate to the worst possible case for the whole outer loop, right? So keep that in mind. That part is very important. Now just print the answer, and that is our thing done. So now the total time complexity would be this n log n plus k, which you can say to be equal to n log n. Why? Because k is less than equal to n, and n log n is will always be bigger than k. So you can say it to be n log n, but if you want to be precise, you can say n log n plus k. And total time space complexity would be O of n, because you are always storing in linear space. So that is the solution. And for the ending remarks, I would say that this problem was quite interesting because it used a lot of different concepts. So first of all, uh, trying to calculate the best possible scenario. So always choosing the middlemost element, that is very important. Then the idea of using a priority queue, right? So here, instead of using a priority queue, you can use a multiset as well. Depends on you, but you want to do this calculation in log n time, right? You can't just iterate over all the values every time. So that is very important. And the third most important thing is evaluation of time complexity. So as I said, some people might evaluate it to n into k log n, which is wrong. So evaluating the time complexity correctly is also very crucial in solving this problem, right? So I hope you like the solution. Thank you.